Hello everyone, and welcome back to another GIS mathematics lecture video. And in this lecture video, I want to go through another example of finding the inverse of a matrix. But this time, instead of using the approach with the equation that we defined, I want to use this approach using the reduced row echelon form. And so what I want to do is I want to go down here, and I want to make a matrix that we're going to use as our example. Is going to be -2, 3, 1, 5. Right, so this is A. Now it is 2 by 2, but we're not going to use our approach from before because I want to demonstrate that reduced row echelon form approach. So to do that, we need to create an identity matrix that matches the dimensions. So again, for a 2 by 2, that's 1s along the diagonal and 0 elsewhere. Right, so this is our identity matrix. We're going to augment them together to give us a new matrix that is going to look like this. -2, 3, 1, 0, 1, 5, 0, 1. Right, all I did was I augmented these two matrices together. So to put these in reduced row echelon form, the first thing we're going to want to do is we're going to want to make this a leading 1. So to do that, we have to multiply the entire row by 1/2. So that's going to be, -1/2 times R1, and then we're going to put that value into R1. Okay, so if we do that, if I lose you in the arithmetic or the algebra or whatever, I encourage you to pause, go back, rewatch the steps until you can follow along. So -1/2 times -2 gives us the 1 that we wanted out here. -1/2 times 3, that's -3/2. -1/2 times 1, that's -1/2. And then -1/2 times 0 is 0. And we didn't do anything to the bottom row, so that comes over just like before. Right, this is also a good review of reduced row echelon form. So the next thing we want to do is we want to make this leading, this 1 here into a 0. And to do that, we just add a negative version of row 1. So this is going to be -R1 plus R2 going into R2. Right, and so if we do that, right, we're not doing anything to the top row, so the top row stays unchanged. Okay. What we're doing is we're multiplying this by negative and then adding it to row 2. So negative times 1 is -1, plus 1 is 0, right? That was the whole point of doing this. -1 times -3/2 is 3/2. I'm going to do this I'm going to do this above here. So we have -3/2 plus 5, right? That's what this is doing. So this is going to be equal to 3/2 plus 5. Common denominator would make this 10/2, right? 10/2 is the same thing as 5. If we add these two together, we get 13/2, which is what we put right here. 13/2. -1/2 times negative is +1/2, plus 0 is 1/2, so this becomes +1/2. Negative times 0 is still 0, plus 1 is still 1, so that stays the same there. Okay? So now our next step is going to be to make this a leading 1. So we're going to make this a leading 1 here. And so to do that, we're going to multiply this whole thing, the whole row, by the inverse. So that's going to be 2/13. So this is going to be 2/13 times R2 going into R2. I'm going to put the answer down here. So we're not changing the top row. We're not doing anything to that row, so that stays the same. Okay. Now our bottom row, right? 0 doesn't change anything. 13/2 times 2/13, that becomes 1, which is what we were hoping it would be. 1/2 times 2/13. I'll do the math up here just to show you that it's going to cancel. But if we have 2/13 times 1 over 2, right? The 2's cancel, and we get 1 over 13. Okay, and then finally 1 times 2 over 13 is going to be 2 over 13 there. Okay, so we do that. Now we want to make this into a 0. So if we do that, right, to do that, we need to multiply this row by 3 halves and add it. So this is going to be 3 halves plus, or 3 halves, I'm sorry, let me erase that. This is going to be 3 halves R2 plus R1 going into R1. Right, and so if we do that, right, this is going to become, the 1s and the 0s don't change. Over here, they don't change. This is going to become 0 because we designed it to be that way. Right, we're not changing the bottom. Then we have this negative 1/2 and 1/13. So let's go ahead and do the math again. I'm going to go up here to do it. So if we have 3 over 2 times 1 over 13, right, that's this first part here. Right, you multiply the top, that's going to be 3. Multiply the bottom, that's going to be 26. Right, and then we're adding to it the negative 1/2, so that's going to be minus 1/2. Now, 1/2 is the same as saying 13/26. So this is going to be negative 10/26, right? Because 3 minus 10 is going to be that. Okay. So this is going to be negative 10 over 26. 1/13 doesn't change at the bottom. Okay, so same thing here. We now have, do a little bit of math. I'm going to go ahead and do it down here. Right, 2 over 13 times 3 over 2. Again, multiply the top. That's going to be 6. Actually, we don't even have to do that because the 2's cancel and we get 3 over 13. So 3 over 13 is going to go here. And then, well, again, we didn't do anything to the bottom, so that's 2 over 13 there. So we can stop, right? This, let me do this in a different color. This right here, right, this is I. And if you remember back, our whole point was to get the I identity matrix on the left side of the augment, and then whatever was left, I'm going to do this in blue, right? Whatever was left on the other side must be our inverse, right? So this does indeed work. So we can pull that out as our A inverse. I'm going to reduce this down to negative 5/13. Hopefully that doesn't screw anyone up. I just reduced the fraction. Right, 3/13, 1/13, and 2/13. And that is our A inverse. So hopefully you were able to follow along through all of that, follow the steps to get to reduced row echelon form, understood why we pulled out the identity matrix and what we were left with. Hopefully that all makes sense. If you have any questions, please reach out. Thank you.